So biogeochemistry is the study of the chemistry of biota. So it's simply the geochemistry behind plants and animals. We always get permission from a landholder to access their land.
We are taking plants and analysing the chemistry. You're literally taking a few of the leaves and taking them away and crushing and drying them and then analysing them.
A tree is basically like a natural drill rig. So we don't have to dig a hole. We can take a few leaves off a tree, and from that we can see what the geology is underground.
Whenever we take a soil sample, you're only really measuring what's in the soil. But if you take a sample from a plant, that plant has roots, and the root system actually taps the groundwater, and so you're getting a much larger footprint of that analysis.
If we have a tree that's tapping into a sandstone, we'll tend to get an enrichment in minerals like silica. If we have a tree that's tapping into a shale, we'll start to see enrichment in elements like strontium and calcium and magnesium. These can then be used to tell us what the underlying geology is for that area. Good morning. So one of the economic benefits of biogeochemistry is we can actually give the results of our sampling back to the landholder, and they'll be able to look at what elements their cattle or sheep or goats are actually consuming when they eat those plants. That's very useful for seeing if there is any hazardous materials that people should avoid, so that their cattle, sheep and goats aren't consuming something that may be harmful to them. So biogeochemistry is an important tool in exploration for minerals and metals, and it is something that is done increasingly because it is a low impact and a low cost technique that has minimal environmental disturbance.